Hello, welcome back. So here's a short lesson on some mole conversions that are a little bit more challenging than the ones we did before. So these are two-step mole conversions. They can actually be condensed, and I will go through that with you. So this is what we've already been through. You know that one mole will have 6.02 times 10 to the 23rd particles. And remember, those particles can be referred to as atoms, molecules, or formula units, depending on what you're working with. You also know that one mole is equal to the molar mass of all the elements in the compound or just the element itself. Now this number comes from the periodic table, and we're going to round all of our masses to 2 decimal points. So what we've done so far is we've converted maybe from mass to moles or moles to mass, or maybe we've gone from moles to particles or particles to moles. Those are just one step, one conversion factor. Now we're going to take a bigger leap. You're going to either start with mass and convert it to the number of particles, or we're going to start with the number of particles and you're going to convert it to the mass. So if you want to get your worksheet out in your packet, where I'm in the mole packet, and you could turn to page 7, Moles, Molecules, and Grams worksheet. I have this as number 7 in your packet. I'm going to work a couple of these for you. So number 1, how many molecules are in 24 grams of iron fluoride, FeF3? That'd be iron 3 fluoride. So here we go. Start with what you know. You have 24 grams of FeF3. We want that unit to go away, so you drop it in the bottom. Now, how do grams relate to molecules? Well, I'm going to do this 2 different ways. The first way, we're going to go from grams to moles. And I know that 1 mole of any substance, in this case FeF3, has a molar mass equal to the number of, has a number of grams equal to the molar mass. So there's a little side problem here. You have to calculate, we have 1 iron, it's 55.85, and we have 3 fluorines. Each one is 19, so that gives you 57. I add these 2 numbers together and I get 112.85 grams. So I'm going to insert that right here. That's how many grams are in every mole. This comes from the periodic table. So if it asks for moles, I'd be done. But it doesn't. It wants the number of molecules. So I know that 1 mole of FeF3, I want that unit to go away, moles of FeF3, so I drop it down here. We'll have 6.02 times 10 to the 23rd molecules. So now 24 times 1 times 6.02 times 10 to the 23rd. Divided by 112.85, and your calculator gives you 1.28 times 10 to the 23rd. Go back for the correct number of sig figs. We started with 2 sig figs, so it'll be 1.3 times 10 to the 23rd. Now you must have a unit and a substance. This is going to be molecules of FeF3. There's your final answer. Now, for those of you who are a little more math savvy, I'm going to show you a little bit shorter method for doing the same thing. You would start with what you know. You have 24 grams of FeF3. Now, if you go back up here, if A equals B and B equals C, then A equals C. So there's another conversion factor there. We know that the molar mass will have 6.02 times 10 to the 23rd particles. So The the molar mass, again, we take the number from that we had up here. We know that 112.85 grams of FeF3 will have 6.02 times 10 to the 23rd particles. I just condensed this step. Instead of having 1 mole is the molar mass, and then 1 mole here is the number of particles, I put it together in one step. If you want to do that, you can. You will end up with the same answer. I have no problem with that. This next one, this is number 3 on your worksheet. If you want to write this in for number 3, how many grams are in 2.3 times 10 to the 24th atoms of silver? So we're starting over here with the number of atoms, and I want to know how many grams there are. So 2 steps, unless you condense it. I'm going to do it as a 2-step problem. Start with what you know. You've got 2.3 times 10 to the 24th atoms of silver. I want atoms to go away, so I'm going to drop it to the bottom. And I know that 6.02 times 10 to the 23rd atoms are in 1 mole of silver. And then I know that 1 mole of silver, I go to my periodic table, it has a mass of 107.87 grams. Put all these numbers in the calculator and you end up with 410 atoms of silver. I have 2 sig figs here, and I have 2 sig figs there. So there's 1 and 3 on your worksheet. Your assignment is posted in Classroom.